problem 3 for masonry construction, and this problem we need to determine the number of bricks required, and they give us the size of one brick, 3.75 times 2.25 times 8. Let in running bond required for double width wall. That is double width, so it's 2 layer as you see in the previous lesson video. And the wall size is 8 feet height and by 14 foot wide, and having one opening. So opening, we have to deduct that opening out. 48 inches by 72 inches. So assume that is a door, and an opening 32 inches by 48. It can be a windows. The mortar joints are 0.5 inch, and the allow 3% for brick waste, break, etc. lost, so that we consider the waste. So what is the number of bricks we need to find out? So first, always we need to know what is the net area required to put the brick in. So first step, we need to determine the net go area. How big the go size is. And that should be the most easy part in this problem. So this goal have 8 foot high and 14 foot wide. So you will have 8 feet times 14. And we have to deduct the opening. The first is 48 times 72. So 48 times 72. And that in inches. So it will be inches square. We need to divide by 144 times 12 times 12, 144 to change it to square feet. And similarly for the other opening, 32 times 48, we have to divide by 144 to square feet. And from that we can get the net go areas equal to 77.33 square feet. So first, and then we need to find out how much, what is the areas that one brick will occupy for the goal. So first, because you have the net goal, go to the slide that we showed in the previous one. So we already know the net area of a goal, and we want to know now to determine the number of bricks. We need to know, okay, so what is the area that the one brick goal occupies, and as I show you here. So let's see you see the brick we are looking at. You see one component. How much the areas that this brick is occupied. So as you can see, it will be occupy half of the mortar in this side, half of the mortar in this side, because we need to consider the mortar here and half up in there. So half on one side the mortar, half on the other side, because the other half go to the other bricks. So you can see one end, one half mortar. We need to it equal to 1 the thickness of the mortar. Similarly for the other top and the bottom, one half, it will be 1. So that basically the areas for one brick that it will occupy in the goal. So from that one, we can go ahead to determine the area of one brick. And the area of one brick that I show you is 2 sides, but we need to add the mortar joints, and in this case 0.5 inches the problem gives us. So we will have the one size with the height 2.25, that's what the bridge give you, plus the mortar thickness 0.5, and then similarly for the other size it will be 8. That as you can see that, and the 3.75 is the depth of the bricks, 0.5 for the mortar thickness. and that is square inch, so we have to find out the square foot. So with 1 divided by 144, and that you will get 0.1623 square foot. Okay, so that you have. So over here, let me write down. This is the length, and this is the height of the brick, and this is the width of the depth. Makes sense? So that is for the brick size. And you can see. So from that one, we have the net goal. We have one brick occupies such area. So what we need to do to just make a division to determine the number of bricks required. So from that, we will get the net go area 77.33 divided by 0.1623, and because double width, that is the double width at the problem with us, just like this here, it double width, as you can see, 1 width 2, so we have to time 2. We have to time 2, so that is for 1 width, and then we time 2. And this stands for double width. And time for the waste, 3%, the problem with us, so 1.03, that is for the waste. So with that, we can get the answer. It will be 982 bricks. And that should be the answer we have for problem 3.